Hello and welcome everyone. Thank you for joining us today for our webinar titled Conquering Time Series Problems with AI and AutoML. My name is Patrick Moran. I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. Gregory Kanevsky is a Principal Solutions Architect at H2O.ai. And now before I hand it over to Gregory, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the Questions tab in your console. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded. A copy of the webinar recording and slide deck will be made available after the presentation is over. Now, without further ado, I'd like to hand it over to Gregory.
Yes, thank you, Patrick. Hello, everyone. Thank you for joining us today. I have quite a bit of slides, so I will probably go in fast, but we definitely leave some time for the questions at the end. So hopefully we will fit everything into 1 hour given. Today's topic is about time series, so I wanted to find some nice quote. I like it a lot for the fact that it really explains why time is important, but also it has been misattributed to Albert Einstein a lot, and errors and misclassifications as part of the game in machine learning. So it's very interesting observation, I think. So the plan today is to go over time series analysis in machine learning, and in particular with Driverless AI, the H2O platform for automated machine learning. This is our items. We will go through them. We will finish with the demo, however time left, and then we will go to Q&A. Quick introduction, just a few seconds about me. I have computer science and applied math master's degree from UT Dallas. I worked in the industry for over 25 years, Reuters, FedEx, Teradata, a lot of software development. Really embraced data science in 2011, authored CRAN package, toaster for Teradata Aster, and very happily joined H2O in 2017. The H2O is around since 2012. It really stands for AI for good and democratizing AI principles. It has been a force in machine learning since it released its open source product for machine learning at scale, H2O3. But since then, we also introduced such product as H2O Driverless AI, as an automated machine learning platform, and we're coming up with more and more products. H2O really creates a lot of interest from many companies and people, as well as from universities. All our products are free, actually, for academia. Over 1,000 universities are using them. You can see that we organize meetups, a lot of people participating and using our products. Finally, I should give credit where it belongs. We have incredible team of engineers, machine learning engineers, and software engineers, and data scientists, including incredible group of Kaggle grandmasters who actually contribute to both the products and clients with their solutions. And you can see the special map of those Kaggle grandmasters on your screen right now. It's I think it's effectively 10% of world's data science grandmasters who work at H2O. So let's go to time series and machine learning. And this will start as a slow introduction, but then quickly turn into very application and how to use it in Driverless AI. So we do look at time series analysis because it's everywhere. Whatever industry you may be working in, whatever use cases you're considering, time component is always there. Sometimes it raises to the level of time series, sometimes not, but you can always find use cases. And I listed some industries and examples here such as economic forecasting, stock market, supply chain, climatology, and of course many, many more, where time series will be intrinsic part of your modeling. So to start with time series, let's define what it really means. So time series analysis is a statistical technique that deals with time series data. What is time series data? It's a sequence of observations taken sequentially in time, and usually a sequence taken at successive, equally spaced points in time. That's quite important for time series. It doesn't have to be always so, but it's very typical and usually critical for many modeling techniques. Intrinsic feature of time series is that those observations taken at different times are dependent. Without that, time becomes almost irrelevant. We also can have cross-sectional data when we work with time series. And that's the actual data taken for one or more variables at the same time, or the same period of time. You will see that we take advantage of that a lot in our modeling techniques. When we combine both time series data and cross-sectional data, we have the so-called pool data. That's the combination of both. And dealing with that combination is very challenging in many cases. Finally, time series forecasting stands for predicting future values based on previously observed values. So what happens visually when I just told you about all these definitions? That's how it all looks. This is our time series. We have two columns. One contains time dimension, and another is variable that is taken at those intervals. In this case, we will work with the COVID-19 cases and deaths in the United States. It's widely available data set and very good for demo, unfortunately. We also have cross-sectional data here. You can see that if we fix a date, we go through several variables such as total cases, total deaths, cases daily, and deaths daily. The pool data will combine it all together. That's our data set. And time series forecasting will attempt to estimate or predict the values for the last dates or dates in the future that we are looking at. In this particular case, this slide was created back in July, and it shows last few days of July to be forecast. So visually, if we take one single time series, we have time dimension, we have our time series data, and we have time period to forecast. So far, so good. How we compose data for time series analysis? That actually happens because we put our data in the long format. Each row in our table is distinct time period. You can see that we defined our time column, we defined our variable column that we are predicting and observing, and that's our time series represented by data set. We can also pick forecast period. In this case, it's a week, 7 days, that we want to predict. That's actually how it will show up in Driverless AI, exactly the same thing. So first, we will pick target column. That's cases daily. That's what we're observing. Then we will pick time column. That's what we will be using as a time dimension. So Driverless AI understands now the data is time series. Then we will define forecast horizon, 7 days. And may drop some other features that we would not want to use. The next step is actually combining multiple time series together. Suppose we're observing US states. So we collected actual time series for each state. In classical time series analysis, such as ARIMA or PROFIT, that would constitute that we'll have to create a model for each of those states. In our case, we don't need to do that. We just have to define time series group, and that will define for us time series columns. I'm sorry. But I'm getting ahead of myself by showing that if we put this data just together as it is, that's what we will observe. It will be one single time series that actually not very recognizable. You cannot differentiate between its sub-series. We call them multiple time series. So how to deal with that? What we want actually to have is this multiple time series where we have the same time, the same variable, but different entities, in this case states, they are attributed to. What we do on the data set I just showed you is to identify this separate time series I marked with boxes, we introduce time groups columns. Time groups column, and it could be actually multiple columns. You can have hierarchical groups with defined, or even it could be not necessarily hierarchical. It could be, for example, product and the store, where you group products by stores, or any kind of grouping that your business supports can be consumed by Driverless AI. Now, when we define time groups column with introduction of time and target, we actually end up with multiple time series, as you can see on the screen. We will have time series for each state. Again, in Driverless AI, on top of what we already did, we need to set time groups columns, which is shown here, and off we go. The system now will model all those time series together into single model. Let's talk now about multivariate time series. The difference here is that we have now observing different variables. In this case, we observed cases daily, but now we want to actually see if parallel depth daily observations help us to predict cases daily. That would constitute covariate depth daily and multivariate time series approach. How we deal with that? We just have another column in our data set, and we define it as a covariate time series. Everything else stays the same, target, time, and this is the place in Driverless AI where you add information about your covariate or multiple time series. In this case, we added just one, but you can add many, many more. In Driverless AI, we call it unavailable columns of prediction time, which means that Driverless AI will look only at the lagged values for that feature, for that column, and those will be considered as another time series to help predictions. Finally, we are at the place where we can combine it all together. We have multiple states, we have multiple time series for those states, and we also have covariates as a depth daily. No problems here. We just follow steps I showed you before. Time, target, we add time groups column, TGC, we add covariates, and everything becomes automatically consumed by Driverless AI. This is again how all this look together in the system. Now I have to say that the more the better for both, for your sake, for the model quality, and for Driverless AI to really take advantage of the signals found in different components, different series, different multivariate series. So this is another example where I combined all US states and many more covariates, many more multivariate series to predict one of the variables. For example, we can predict cases or deaths using all of them in one model. So now when we understood how we represent and consume time series, let's talk about driverless AI approach to time series modeling. So this picture actually is too big to really spend a lot of time on it, and it talks about generally driverless AI platform. That we go through multiple steps in one single automated workflow for each model, where we start from data prep, we go to setup and validation, feature engineering, model selection, predictions, and then finally deployment. All these steps are highly automated. In fact, if you take 1 through 4, that's one single step, and then deployment and analysis follows with another set of tools and artifacts we create and deploy. Things to note here that we consume multiple formats, we auto-parse data, we can go to different clouds, databases. We will provide you with automated data visualizations on the data if necessary to find interesting facts. Everything also is extensible. There are recipes for every step of the way. That's the next level of working with driverless AI. Setup and validation is an important step where we will look at your data, determine data leakages, data shifts. We will create robust holdout or cross-validation schemas. We will use sampling if necessary, if data is too big or unbalanced. We will handle missing and unseen levels and balance. Then, very important step where we will use a lot of secret sauce transformations, feature engineering, model selection and tuning to come up with the best model and ensemble. And finally, you will have opportunity to look at all that using our tools to analyze data for model diagnostics or MLI, machine learning interpretability. This is actually basic driverless AI. This is not even time series driverless AI yet. This is foundation on top of which we now put the special features for driverless AI in driverless AI for time series. What are those special features? I tried to map out here, not everything. It's again, you have to go to documentation for everything, but to map out some more important aspects of our approach to time series in here. For example, we will automatically handle periodic data, including irregularities, if there are not too much of them. As I showed you before, we will handle time groups to create multiple series. We will handle multivariate time series. We will differentiate between feature known and unknown in advance. After that, we will go to setup of our validation skill for backtesting, where things like gaps, forecast horizon play very important role. Target transformers, where we decide if something should be done on target. We'll have set of flexible expert settings for when you become much more familiar with driverless, and we will talk about that later. To adjust workflow based on the use case, based on your business needs. Then driverless AI will use a variety of transformations and feature engineering to model time series data. It will use autoregressive transformers, exponentially weighted moving averages, various aggregates. It will extract date-related features, time and date features. And you can also customize it with recipes. For example, you can add profit, ARIMA to the mix. Finally, our predictions modeling, like rolling window-based predictions, will use most optimal approach. It's either test time augmentation or refit, and all the deployment options available with Driverless AI also available for time series. We automatically generate scoring pipeline. We have visualization of time series and predictions, and also explanations. Now let's go into let's pick into few details of what I just showed. So for example, this is how we generate lagged features on for time series model. And this is something we always do to automatically to create data set, internal data set that will be used by the algorithms like XGBoost or TensorFlow and so on to create models. So you can see that given one target, one column of target, we will create multiple lags. And those lags I just showed you 3 lags. It could be hundreds of lags based on how data structured. We will determine those lags based on autocorrelations and tuning. We will also extract date features from dates. This is, again, just an example. Day, month, year, weekday, holiday, but it can go to anything it includes anything you can think of which relates to time and date. Holidays, weekdays is another example what can be extracted, but we also give you opportunity to expand it with your business-related transformers or features that you may extract. For example, if we are talking about time of day, you can structure your day into different parts. For example, typically day sometimes 24 hours divided into 4 periods, and you can write simple transformer to extract those periods and add that to this data. Other feature engineering that Driverless AI performs, feature aggregation at different levels and with different functions. So as I mentioned before, window and moving averages, exponential smoothing, variety of descriptive statistics, lag interactions, all that automatically included. We will do actually regularization of lag features using dropouts to prevent overfitting. We will replace randomly some values with nulls. Lag selection is important to time series. We will use autocorrelation and some predefined approaches. For example, if it's daily data over a year or months, we will look at 7 days period and so on, or monthly 30 days period and so on. We will also use target transformations like differentiation or univariate transforms. Finally, custom recipes allow you to plug in ARIMA or profit if you want to compare and see how they benefit or compare to what our algorithms do based on gradient boosted machines and GLMs, logistic regression. We can also add, we also have other examples of custom recipes like volatility, stock volatility, or local holidays. Finally, when all this feature engineering is done, we feed it into the set of most suitable algorithms and then select the best ones. So typically, we will use LiveGBM, XGBoost, H2O algorithms, TensorFlow, and that's all will be stacked up, run on using backtesting and our validation schemas to determine what works best on your data and data sets to select a winner and final model. But there is always iterations, and you will see how that works soon. Important part of time series analysis and modeling is backtesting. So a driverless automatically determines optimal validation splits on your training data, as you can see, and rolls them across all data available. This is sometimes actually one of the most critical parts of how to achieve the best model. And that's why we allow you also a lot of customizations here. But everything again is taken care of automatically. When your model is done, it's actually computed and designed to predict exactly on the forecast horizon you specified. That creates some tension with machine learning engineers or your DevOps who deploy models, among other problems. Because while your data may be changing every day, it's sometimes not very feasible or too expensive to train models every day. So for that reason, we created certain approaches to predict on your data set. And we have two approaches to offer. As you can see, they both will be solving the problem on the screen when your predicting or test set in red goes beyond forecast horizon. Like component 9 here, time element 9 is what forecast horizon was designed for, but we really want to predict longer with the same model, 10, 11, or 12. So what we will do either of two things. One is test time augmentation, is when we take existing model and we will recompute all features for the time given value in time 9. So imagine that we know what value of our predicted variables is, so we can consume it, recompute all the features, and now we can actually predict for element 10. So that's the second from the top row here. Then we take 9 and 10 as test time augmented features and compute predictions for element 11, and so on and so on. So that way, effectively, we will use the same model and we will just recompute features, recompute features on data augmented for 9, 9, 10, 9, 10, and 11. This is very effective way in production to make predictions without model changes, redeployment, and so on. It's fast, but the only one cons, the most critical cons here, the problem is that you are not actually training your model. You're just pre-computing lags and pre-computing those transformations that the model is using. So if some core behavior, core trends changed along the way of this TTA period, then this model will start degrading very fast. And effectively, they do degrade over time. So the second approach would be actually extending train and refeed. And that's what we will do as a second option. To get valid predictions for the whole set, we extend the train set with the latest data and refeed the original model to generate precise prediction. So that would be the most optimal approach, most efficient, but the problem with this approach that it's time consuming and it needs model redeployment. Finally, I wanted to spend a few moments to talk about what kind of use cases we can cover with driverless AI. So the top left corner here, this is use case where your data already have lags as features and you don't really need to do time series, but your data is time-based. So you can do what you can do in driverless AI, you just specify time column and disable lag-based recipes and transformations. That's the expert settings in Driverless AI that you can do in one shot, so your data will be treated as time-based, all validations will be time-based, but no time series or lags will be considered or used. The second one is what we discussed so far a lot, that's time series forecasting, where we, given the data, we will forecast its future values, and we can use multiple time series at the same time. We can use multivariate series as additional features. This is all great. The next case is when we customize it a little bit to actually predict single outcome based on time series. Driverless AI will do this if you disable lag on your target. That's one of the expert settings. You will set forecast horizon to 1, just one single value, set it to constant value, and then use everything else just like before. Effectively, we now will process input time series, multiple time series, as our covariates, not multiple time series, but multivariate time series as inputs to predict one single outcome. And finally, with some effort on data prep and customization, we can actually implement transfer function models and solve transfer function use cases where we map one time series into another. That's not trivial. That will require some data prep and tweaking the data, but it's also possible with Driverless AI out of the box, plus validation splits and data prep. Let's talk about some hints and gotchas in Driverless AI. This is quite advanced, but that's why we really believe our product is very powerful. Where it becomes most powerful is its customization options. Time series by itself, it's naturally not a trivial modeling exercise. If you start in any use case, could it be COVID cases predictions or some supply chain demand forecasting, you will always find something special in your use case that throws it off, that makes it different. That's why we have extensive set of expert settings to really work with Driverless AI to adjust and adapt to your use case. Next advice is always try to collect sufficient amount of data before you predict future. I don't think anyone has been able to predict future without knowing past, at least yet. And by meaning knowing the past, I mean a lot of it. So our minimum requirement, we don't enforce it in data, but that's our minimum requirement in documentation, that you should have at least 3 times training data as you have data to predict. So if your forecast horizon is 7 days, then collect at least 21 days of data to train. Definitely, when you build time series models and you create and you predict for longer forecasts, your results will suffer. So never try to predict for time longer than you really, really need. If your business sets the goal to have predictions for next 3 days, don't give them whole week of prediction. It will affect a lot more than just quality of predictions. It will affect your deployment strategy. It will affect DevOps and a lot of other things related to it. It's much more efficient to predict for 3 days and set requirement that every 3 days your model should be either updated or test time augmentation should run or something like that. That's definitely something you should be watching out for. TGC, which stands for time groups columns or time group multiple time series, is very powerful feature in Driverless AI. the more data you can collect together to create single model, the better. So for example, if you have multiple branches that are multiple stores for which you need to make predictions, put this data together and create single model. Even though those predictions are not at the store level, for example, but at the product and store level, we will still be able to find signals between the stores and between products that will enhance predictions, hopefully, if that signal exists. Otherwise, when you predict for each product or each store product combination, you have no power to use signal between products and between stores to predict, to make better predictions for each product and store. I have talked about TGC, and then this next point is actually very interesting. This is where your TGC, time groups, columns, is actually multivariable. So just like I mentioned before, we want to predict per store and product. That means that your TGC contains two columns. That actually creates opportunity for us in Driverless AI to aggregate data at both product level and store level, besides the fact that we will aggregate it at combination level, and see if those combined aggregated time series have interesting trends that can be used as a signal for the model. So that's another thing to be aware of and remember. Our MLI tool, machine learning interpretability tool, explores both model errors and forecast with explanations. So that's another tool you can use to analyze your model. Now we will finish the slides with the certain hints and advices for expert settings. This is pretty advanced. I will go over this fast, but you will have opportunity to come back to it when you start using Driverless AI and or look in the documentation to see how you would use it and why. So as I mentioned before, if your data is time-based, not IID, and already contains lags, just disable lag-based recipe. And then our models will validate and use data splits only on time-based. We will avoid overfitting that way. Using smallest considered lag size setting and time series lags override will let you customize lags in your model. We will determine lags automatically, but you can always override it. And a lot of people have some business knowledge when they know in advance which lags are actually important. For example, retail, they know what monthly, weekly, or certain bi-weekly lags, and so on, so they can include them explicitly. We most likely find them ourselves, but if you need to override it and avoid something, you can do it. Time groups columns as a standalone features, that's something you should be using to extract more information from your multiple series and aggregate across series. Disabling always group by all time groups related to that. That's exactly where you find signal where you cannot find it because without combining multiple time series together. That's the setting that you should use. We do analyze time series for detrending, and we have mechanism to deal with that. And that's also in expert settings where you can enable and modify how we do it. So it's time series centering and detrending that you should be aware of and look for better performance. And finally, validation splits are very critical for time series. So you should be looking at various options in expert settings if you need to play with them, how to change and modify them. And I listed here three of those settings where you can define custom validation splits, you can define number of the splits, and you can define maximum number of splits used for creating final time series models, holdout predictions. But there are more. So with that, I will stop sharing my slides and will show you what time we got on time. We'll spend a few more minutes on showing you driverless AI. Let me see where this ends. Here we go. You should be able to see my screen now with driverless AI. I will quickly show you how to load data and then show you the experimenting part. When you navigate driverless AI, here on top, you see multiple tabs. I just clicked on data sets where your data lives. Out-of-It is where your automated visualizations found. Experiments is where the models are. Diagnostics is where the diagnostic of models saved, and you can go to them. MLI is interpretability module, where machine learning interpretability models live for created experiments, or actually even for external experiments too. Deployments is for deployment. So that's your basic navigation. I go back to data sets, and I can load data from a variety of data sources. That's what enabled on my system. But if you look at the documentation, you can customize it for a lot more of different data sources based on your IT environment, including databases and cloud storages and so on and so on. I will actually bring data using data recipe. I'll just show you how quickly it works. And data recipe, you can find it. It's in our repository online. It's H2O Driverless AI recipes. I navigated to data, New York Times COVID-19 cases. All I need is just to take URL here. And I will explain to you what it does in a second. Go to data recipe URL, enter URL, and say save. I think it will give me the, no, it will not, because I haven't loaded it today. So what's going on now is these two data sets were created, new data sets, with data that New York Times posted on GitHub on COVID-19 cases. And you can see that one single recipe created two data sets based on my requirements. I created last 7 days to test. That's my train, that's test with the 364 rows, and all previous data to actually train. If you look at the data set, you can look at details and see that it contains date, state FIPS, and then metrics such as cases, deaths. And if you look actually at data set in New York Times, that's it. That's all it has, cases and deaths. But what data recipe added on the fly, it actually retrieved populations. It also, for each state, it also can find it online. It knows where to find it. It computed then cases and deaths per 100,000 of population for each state, which is basically, you can think of it as a normalized metric. And it also computed daily cases and daily deaths based on the differences between consecutive rows. That's all done inside the recipe. So that's the power of our data recipes. You have to spend some time to create them, and then they function as implicit ETL tool for you. And of course, you can put much more complex logic into this code. You can see that the code here is not that long. It's just a few lines where we retrieve file and then apply transformation I just listed. By the way, this is open source. This is public repository. You can always take a look at it and use it and reuse it with or without drivers. Now I will switch to the tab that I actually haven't shown you before. It's projects. And I have project created for my experiments now. For example, US baseline project and experiments that I created before. On the left, you have data sets. There are two folders here, training and testing. And on the right, you have experiments created only for these data sets. So project is a very powerful environment to focus on a single use case or maybe family of use cases related. Like here, I have predictions on US states, but also I have predictions on the total US without states, just single time series, just for fun, even though it's not fun to look at this data. And I have created a few models, but I will start with the new model for now. So if I click on my model, on my data set here for training, I'm in training folder, and say predict, then Driverless AI starts the screen that I showed screenshots of which before. I start with selecting my target. Let's stick to what we were doing during the slides, cases daily. Immediately, Driverless AI computes all statistics, realizes that it's regression, and gives you default score for regression. It doesn't know yet that it's a time series. I will attach test set next that was created automatically with my recipe. Let me attach it here. And next, I go to and define time column. That's where we do trigger time series, and our time is date. So now the right panel appears here that actually defines time series at the high level. Let me specify now time groups. Remember those? That's our state. That's the time group. So now Driverless recomputes it for time groups I defined and understands that there are as many time series as there are states. It actually, as you can see, it already parsed time series based on groups, determined test set time span, automatically set forecast horizon, the size of the test set. I will not change it, 7 days. That's what I want. That's usually what you want to do. It determined frequencies, that it's 1 day data. Let me drop some features that I don't need. FIPS doesn't mean anything anymore. Population by itself, not needed for 1000, but everything else I will leave here. And finally, I'll open unavailable columns at the same time and click on those that also time series. And that's basically everything here. So now Driverless AI ready to go. Let me change it to estimate. Ready to go, and we can create our model. There are a lot more to it. You can see the plan on the left. You can see high-level settings here. You can see expert settings. That's where you really drill down into how our workflow works. There are different tabs. One of them is time series, and that's how much customization power you have. Again, this is not what you want to do immediately, but only by necessity and when your use case demands changes. We will work with you definitely on both explaining and helping how to use them. Let me cancel out of here. And finally, I can just launch experiment. At this settings, it will run for a long time, but I already have experiments running. Let me see what is, maybe it's still running. I have this running and nothing else. So let me go to similar experiment that has completed to quickly show you what we have, and then we will go to questions. What we end up with when model is complete. So that's your, here we go. right here. This is finished experiment. You can see here on the low right corner, the summary of what we've done. We started with the validation score of 37. We ended up with validation score of 32. This is SMAP, symmetrical mean absolute percentage error. And actually test score is pretty good too. Actually excellent test score, which is in complete sync with validation score here. So that's the model that you want to have. Now, you can see that during this period we created, that's how much time we spent, that's how many features we tried here. So this is how many models we created. This is how many features. Hold on, where's the, I'm looking for the features and I kind of lost in the product. But, okay, here we go. So this is how many features driverless AI tried and 48 selected. And when you look at the features itself, these are 100% time series, target lag, or exponential moving averages, and so on and so on. The final model you can see here is XGBoost. That's the model that fed all these features. Actually, this is not the full list. It's just top 15 or so features. You can download documentation. You can download scoring pipelines for the model, deploy it or investigate. You can also go to diagnostics, even though some diagnostics is available here, both on test and validation. And also, one important piece is our MLI tool, which allows you to look at the errors and also look at each time series separately to see how predictions and holdout and vary, and click on the points and then observe actually explanations based on Shapley values. So I will stop here for the questions. Patrick?
Great. Thanks, Gregory. We do have a lot of questions waiting for us. First thing, though, I want to start the voting on our poll. If everyone could just participate whenever they feel like it. The question is about how you're currently solving time series problems. While we're doing that, we can go ahead and answer a couple questions right here off the bat, asking about the slides. The slide deck will be available under the attachment section shortly after the webinar is concluded. And the first question here is it possible to customize the formula used for accuracy measurements to align it to how it is measured in our organization?
The accuracy, if by accuracy you mean score here, yes, it's completely available. Let me even, it's called score recipe. I can open like the experiment here and I will show you in a second where it's done. So you go to expert settings, recipes, and here you have specific scores. You load score, you can load custom recipe, just like I loaded data recipe before, and you can find examples actually of those in the same repository under scores. And we have a lot of examples, possibly already something that you're looking for. So we have examples for fraud, for other places. Something like log loss with costs is it's a customized score based on actually transaction value, which is read from data. So it's pretty advanced. I hope I answered the question.
Great, thank you. Next question. Do the R or Python H2O packages include tools to reproduce these types of predictive analyses, such as rolling window, TTA, refit, windowed backtesting?
Yes, so I do know that some time ago, even Python and R clients to driverless were even more powerful than our UI. For example, some customization options, at least one I knew about as documented, is available only from the tool. from the Python or R packages. But that's kind of very advanced stuff. But everything I show you done through API, which is the same as our Python or R clients for driverless. So hopefully, if person who asked that question meant Python client and R client packages for driverless, then the answer is yes.
Great. Next question, is there a way to do active learning with time series or some sort of transfer learning with time series?
Yeah, good one. So I don't think it's possible right off the bat, but we can work on some customizations, maybe using recipes to try to achieve that. Again, the whole workflow that I showed you, it's automated. It goes through like without any input from the user, but you can customize it before it starts. So by active learning, you may use our Python client or R client and have driverless AI to create models actively. So there's some customization definitely expected here to even approach that. Yeah, I would also mention our new code-named product code-named Q that is coming out that does create apps exactly for that purpose, that utilize driverless AI and H2O for applications like this. But so please find resources and maybe ask me separately on LinkedIn or Twitter, and I will be glad to help.
Great.
Thanks.
Is there a way to fit general state space models too, or a Kalman filter at least?
So I would say probably yes, but I haven't tried that. So general states, can you repeat the question? State space, you said?
Yes. Is there a way to fit general state space models too, or Kalman filter?
So Kalman filter is pretty simple in my view, but general state space would probably be possible. It's all about your data prep and how you design data. Again, we are not doing any magic outside of data transformations and model selection and tuning in our workflow. So if something is missing, we can always plug in recipes for both models and transformations, and usually for supervised learning, which we cover, that works.
All right. Probably got time for two more questions here. How is validation score calculated? Why are test score and validation score should be close to each other? Let me repeat that. Why test score and validation score should be close to each other?
Well, they don't have to be closed. It's just a nice sign that they're closed. So what I showed you, they didn't diverge too much. Again, it's not they do not have to be. The validation score is calculated on those multiple splits we have, and then we will show you the average. And test score is just a single score of the whole test set.
All right. Can we have these models exported and deployed in my company's on-prem environment?
So for that reason, we have two techniques, two options with scoring pipeline, and that would be either Python scoring pipeline that requires Python environment, or our Mojo scoring pipeline that actually is supported by a variety of environments from C++, Java to R. So the most definitely answer is yes.
All right. And final question, how to predict human activities like problems? How would you structure the data?
Yeah, this is very open-ended question. Very interesting problem. Human activity, well, start with defining things, always. So whatever you mean by human activity, structure it, categorize, and go ahead. Maybe it will be successful. So far, I think human activity is not very tameable thing outside of simple churn models or clickbaits and so on. But hey, we're working on it.
All right. I think that does it for all our questions today. I want to thank Gregory for taking the time today and doing a great presentation. I'd like to say thank you to everyone who joined us today as well. The presentation slides and the recording will be made available on our BrightTalk channel shortly, and we hope you have a great rest of your day.
Thank you.